Hey algebra students, we're going to take a look at 5-8 trial and error factoring with negative constants. So the same idea as the positive constant. We still have that coefficient of 1 for the first term. So looking at the warm-up, this is with that positive constant or the positive last term, even though it's not a constant for this warm-up. We want to look for a greatest common factor. There is none. We look for the pattern of difference of squares. That's not there. We look for a perfect square trinomial. Since 8's not a perfect square, we would move on to the trial and error. We take the square root of the first term. We're looking at that s squared, so I'm going to put that in as the second term. Now, because that sign is a positive, I know that I need the signs in the binomials to be the same. And because the middle term is a positive, I know I need that sign to be a positive. So now I'm looking for factors of 8 that will add up to 6. And so that, of course, is 2 and 4. And then I can FOIL to check. For the next warm-up, again, I'm looking for a greatest common factor. I don't see one. I look for the difference of squares. That pattern's not there. Then I would continue looking for my trial and error pieces. Or perfect square trinomial, 20 is not a perfect square, so continue with what we've been working on. I take the square root of the first term. I'm looking at that positive, telling me that the signs have to be the same because a negative times a negative is a positive, or a positive times a positive is a positive. And the middle term being a negative tells me that my signs are negative. Now I'm looking for factors of 20 that will add up to 12, and of course that's 2 and 10, and that's my factoring for warm-up. So hopefully those ideas still fresh in your head. So we're going to look at how to factor with negative constant. The first term here is positive, at least in these examples that we're going to look at. And then the constant term here is negative. And that's the different kind of example we're looking at. Now that negative constant term, or that negative last term, even if it's not a constant, tells you that you're going to have a positive, a plus, and a minus in your binomials, because it's that plus, that positive times negative, that gives you a negative product. So that's what's different about these than the last ones we've been doing. So like the last examples, we take the square root of the first term, and that first term is y squared, and so the square root of that is y. So we're going to place that y in each spot for the binomial. Now, the difference here is that this last term is a negative, and that means that we're going to have a positive and a negative, or a plus and minus in the binomials. And then the factors of the last term, we're looking at factors of 12. And so we're looking at 1 and 12, and 2 and 6, and 3 and 4. And since there is a 1 in front of the y, like that is a 1, we want factors that will subtract to get 1. So we're looking at subtracting to get 1. The reason we're looking at subtracting is because the signs are different here, and so that's different than last time when the terms were positive and we were adding to get that. So we're subtracting to 1. So that's going to be 3 and 4 that will subtract to get 1. Now I need a positive middle term, and so I want the higher value to be positive, and so I'm going to put the 4 with the plus and the 3 with the minus, and that way when I add them I would end up with that positive 1. Now, you know, you can, sometimes you'll try other ones here and you'll guess and check, and you want to make sure you can FOIL it out to get back to what you should get back to. Okay, and that of course is your final answer. Okay, now we've got this labeled as your term, and I'm going to help lead you through it here. This is a little bit different. We want to pull out a negative. We've got that op sum in reverse because we don't have that negative, that positive 1 coefficient as the first term, and having that positive 1 is best for factoring. So I would take the value of negative 1, and that's going to change the sign of everything else. And then you can see I have that negative constant. So now I've got negative 1 times each piece, so I have that negative 1, and that is times each value. And I want to break that down. The first term is y squared, and so I want to place a y in each binomial, and I want factors of 14 that subtract to get 5. So I want to think about that. I want to think about factors of 14 that subtract to get 5. So, and I know I'm going to have two different signs because I have that negative 14, that negative product, which means I need opposite signs for each binomial to get that negative product. And again, I need to subtract to get 5, and because that 5 is negative in the middle term, I want the higher value to be the negative one. And so again, thinking about factors of 14, I've got 1 and 14 and 2 and 7 right there, hopefully realizing, hey, that gives me a difference of 5. And again, because the middle term is negative, I want the higher value, 7, to be the minus 1 or the negative 1. And then I've got 2, and you can check that with FOIL, and of course then your final answer is that. And again, you always can go back and check with FOIL. All right, so taking through just some other examples, we've got that middle term, or the first term of m squared. So making my binomials, again, always looking for if I can pull a greatest common factor out. It doesn't make sense to pull out a negative 1. Is there a difference of squares? Is it a perfect square trinomial? When all of those things are ruled out, then you start to do with this trial and error piece. And so I've got square root of m squared, which is m. My last term is negative, so I know that I'm going to have different signs. And I want factors of 5, which of course are just 1 and 5, that are going to give me a difference of 6. Now the issue with that that's really tempting is it's tempting to drop those in there because you're like, okay, 1 and 5, 6, but the key here is that we need it to be a difference of 6 because of that negative, and that's going to give me a sum of 6, not a difference of 6. So this, in fact, is not factorable, or you could label it as prime. All right, now for the next one, let's take a look. We are looking at, again, greatest common factor, nope. Difference of squares, nope. Do I pull out a negative 1? No. And then you continue. Square root of x squared is x. My last term is negative, so I know I want different signs in my binomials. I want factors of 20 that give me a difference of 1, or negative 1 there, a difference of 1. And so 1 and 20 are not going to do it. And I've got 2 and 10, nope. 4 and 5, that will give me a difference of 1. Now because my middle term is negative, I want the higher value to be with the subtraction, so that my middle term would be that negative 1. And then our last practice here, again, breaking it up into two binomials after I've looked for a greatest common factor, after I've looked for the other patterns. I've got x squared. My last term is negative, so I know the signs should be different. I'm looking for factors of 12. That will give me a difference of 4. Hey, there it is. Because that 4 in the middle is negative, I want the higher value, 6, to go with the negative. And then for this one, I just have to make sure I put that k as square root of k squared in there as well. Again, you can always FOIL to go back and check to make sure you end up with what you should end up with. All right, make sure you bring your questions into class, and we'll see you soon.